Greetings all, I am Nalinakshaa from BE 2 third year and I am here to explain the solutions for the two problems provided to me at RECode contest conducted by Coding Club. So now let's quickly take a look onto the first problem statement. So this states that given an m cross n integers matrix, return the length of the longest increasing path in the matrix. And from each cell, you can either move in four directions, that is either left, right, up or down, and we may not move diagonally or move outside the boundary, which means that we can't go outside of the grid. So now let's see the input and output format for the same. So as an input, we will be given in the first line with the number of rows, then with the number of columns, and then with the actual elements in that m cross n grid. And afterwards in output, we will be returning the length of the longest increasing path that we find in the grid, which will be a single integer. And now let's see the code constraints. So as code constraints, we will be having the number of rows ranging from 1 to 4, columns from 1 to 4, and similarly each element in a matrix will be taking a value from 1 to 20. So now let's see the example for the same. So in first example, the longest increasing path is found to be the path 1, 2, 6 and 9, which is consisting of a length of 4, so we will be returning 4 as output. In the similar way for the example 2, the longest increasing path will be a path 3, 4, 5, 6, which is again of length 4. So hence we will be returning the length 4 as output again. So now let's see the algorithm. So before that, we'll see what kind of approach can be used in order to solve this problem. As we all know, normally when we are given with traditional problems like finding the path from source to destination, or like finding the shortest path from source to destination, or like finding the longest increasing path in a grid. So in all such cases, we will be going for the depth first search or the DFS approach. So normally if we use DFS, it is a recursion. So when we solve recursion, it would obviously take an exponential time complexity, and hence it is not going to be the optimized approach. So now to optimize the same, we can use the combined approach of DFS plus the memorization in order to solve this problem. So why do we use memorization? So normally memorization approach in dynamic programming is used to store the previously computed values so that we need not recompute it in our near future while we need it. So hence let us see an example for that. So here in example 2, a longest path in a grid is found to be the path 3, 4, 5, 6. So normally how do we find the longest path in a grid? So the longest path in a grid can be found out through the maximum of the longest path through each cell in a grid. That is, we find out the longest path for the first cell 3, the longest path for the second cell 4, and so on up till the longest path to the last cell 1. So we will be finding out the maximum among all these paths in order to compute the longest path. So when we say we are going to find the longest path of the first cell 3, it is through the longest path of the second cell 4, which is in turn through the longest path of the third cell 5, which is in turn through the longest path of the sixth cell, which is 6. So hence, while we are computing the longest path through the first cell 3, we are computing the longest path through 4, 5 and 6 also. So hence, after finding out the longest path through 3, which is 4, we will be next moving on to compute the longest path through 4, which is 3. But since we have already computed the longest path through 3 and 4 is involved in it, we need not recompute it again. But when we go for a traditional recursive approach for DFS, we have to recompute it again, and since it is an overhead, we go for a memorization approach where while finding out the longest path through 3, we will be storing in the memorization array the longest path through 4 also. So hence, while computing the longest path through 4, we need not recompute it again, and we use the previously stored result in the memorization array. And this is the advantage of combining the memorization approach with the traditional DFS based recursive approach. So now let's see the algorithm for the same. So our first step is to create a memorization matrix in order to store our intermediate results. And then we have to define the possible movement directions, which are down, right, up and left as seen in the problem statement. And now we have to iterate through each cell in a grid, and for each cell we will be calling DFS in order to find the longest path through each cell. And in DFS we will be having each cell. So for that each cell, if the DFS is already computed, which means the longest path is already computed for the cell, it will be present in the memorization array. So we will be just returning out that stored result, which can be seen as one of the base condition for this recursive DFS. And then if the result is not already computed, then we have to compute it for sure. So hence, in order to compute it, our first step is to initialize the variable max length to be equal to 1. And then we can move in all 4 directions if the next cell has a greater value, which means that we can explore in 4 possible directions. And while exploring in those 4 possible directions, we will be checking if a new cell computed is within the bounds of the grid. And after that, if it is within the bounds of the grid, we will be checking with the values. So one constraint which we have encountered here is that we are going to find the longest increasing path, which means that the next cell whose value is going to be computed must be greater than the current cell's value. So that condition has also to be checked. And after that, if these 2 conditions hold true, we can recursively make a call to the DFS and then finally update the maximum length for that particular cell. And finally, we will be storing the result in memorization grid. So this happens while exploring each cell in a grid. And finally, after exploring, we will be keeping track of the maximum path length for each cell in a grid, and finally we will be returning the same. So now let's take a quick look onto the code for the implementation of the same algorithm. So initially, as said, we will be taking as input the number of rows, then the number of columns, and then the actual elements of that grid. And after that, we'll make a call to the find path method, which will in turn find out the length of the longest path, and we'll be printing it. So now let's see the find path method. So before that, we are having a static integer array, which is directions. So as said, we can move in 4 possible directions, which are up, down, left as well as right. So we are initializing it through the directions array. So we have 1, 0, 0, 1, minus 1, 0 and 0, minus 1 in order to indicate the 4 possible directions. And after that, we have the find path method, which is a static method. So this find path method takes as input the total number of rows, total number of columns and the actual grid, and it is returning the maximum path found in the grid. So initially we are initializing the memorization array with the same size similar to that of the grid size. And now we are initializing the maximum path to be equal to 0 initially. And as said, we have to explore each cell in a grid. So while exploring, we will be calling DFS for each cell and we will be updating the max path accordingly, and finally we will be returning the maximum path after exploring all the cells in a grid. So now let's see the DFS method. So in DFS, we are given with memorization array, row and column combination will give us the actual cell in a grid for which we are applying DFS. And then we are given with the actual grid, and M and N denote the number of rows and columns respectively. And as said, our first base condition or the termination condition for this DFS based recursive function will be to find out the value at that particular cell in the memorization array. That is, if that cell in the memorization array is not equal to 0, it means that we have previously computed it. So hence we will be just returning the previously computed value without performing any work further. And what if it is not computed? We have to compute it. So in order to do that, we first initialize the max length to be equal to 1. And for that particular position in the grid, we have to explore all possible directions, which is left, right, top and bottom. And for each cell or the new position in the cell which is found, we will be checking for the 2 conditions as I said. It means these 2 are, it must be within the bounds of the grid, and the second one is the cell that we have chosen must have a value greater than the current cell. So these 2 conditions are checked by, the first condition is new row must be greater than or equal to 0 and less than m. Similarly, new column must be greater than or equal to 0 and less than n. This satisfies the first condition. The second condition is that the newly chosen cell must be having a value greater than the current cell. That is, array at new row new column must be greater than array at row column. So if these 2 conditions are satisfied, we can explore the new cell. We explore the new cell by calling the DFS for that new cell. And when that new cell returns, we will be adding 1 to it and updating the max length accordingly. So finally, at the end of the for loop, we will be updating the memorization array with the max length and finally return the max length to this find path method. And this find path method in turn will find the maximum path and it will return to main method, which in turn prints the maximum path which is found in the grid. So now let's see a tracing here for the same. So we are given with a 3 cross 3 grid with the following elements. So here we are asked to find the maximum path. So as said, we will be exploring through each cell in a grid in order wise, that is first, second, third and so on. So considering the first cell which is 3, we are going to find the maximum path through 3. So we can go for 4 possible directions, but we can't go left and top since it is out of the bound. So our only possible values are right as well as down. So when we consider right and down, when we consider down, it is having the value 3, which is equal to 3 again, and there is no use in exploring because it is having the same value as that of 3. And the path has to be increasing, which is one of our constraints specified. So hence we can go only to right, which is having the value 4. So hence if we go to 4, what does it mean is that the maximum path through the value 3 is 1 plus the maximum path through the value 4. In a similar way, when we look for 4, we can go in 3 possible directions: left, right and bottom. There is no use of exploring left as well as bottom since 2 and 3 are less than 4, and our only way to explore is to explore through 5. So when we go through 5, it means that the maximum path through 4 is nothing but the maximum path through 5 plus 1. In the similar way, considering for 5, the maximum path through 5, we can consider the 2 directions, left as well as bottom. So left is having value 4, which is less than 5, so we consider only bottom case. So when we go for bottom case, it is 6. So hence the maximum path through 5 will be 1 plus maximum path through 6. So considering the maximum path through 6, finally we can't go anywhere. If we go up, 5 is less than 6. If we go to the left, 2 is less than 6. And if we go to the bottom, 1 is less than 6 again, and we can't go right since it is out of the bounds of the grid. So finally we end up having the maximum length for 6 to be equal to 1. And as said, we will be returning it recursively. So the 5's max path will be 1 plus 6 max path, which will be equal to 2. And then similarly, the max path for 4 will be 2 plus 1, 3. And max path for 3 will be 3 plus 1, 4. So now we have found the maximum path for 3. And now our next step is to find the maximum path for the next cell in our grid, which is 4. So while finding the maximum path for 4, we find that we have already satisfied the termination condition. That is, we already have a value for the cell 2 in our memorization grid. So we just return that. So our maximum path for 4 is 3. So here is where we prune the unrequired things that is done in the traditional recursive approach by using memorization. And in a similar way, while looking for the maximum path through 5, we just return the value, which is 2. And now we are looking for maximum path through 3. So we can go either up, right or down. And all these values are either less than or equal to 3. So we will be retaining the maximum path through 3 to be equal to the 1 again. And then now looking for 2. So we can either go to left, right or top. So, or bottom also. So we have 4 possible cases here. But bottom is not considered since 2 is equal to 2 and it is not increasing. So we have 3 possible choices: left, top and right. So now we have to find the maximum among these 3. So how do we find the maximum among these 3? So the maximum path of 2 will be the 1 plus the maximum path of 3 or 4 or 6. So considering these 3, the maximum path through 3 is 1, through 4 is 3 and through 6 is 1. So the maximum among 3 is maximum path through 4, which is 3, and doing plus 1 we will be getting the maximum path through 2 to be equal to 4. And now looking for the next element, which is 6, maximum path through 6 is 1, which I have already computed in the memorization grid, and we just return it. And now looking for the maximum path through 2, we can explore 2 possible directions, up and right. So when we go up, the maximum path through 3 is 1 plus 1, which will be equal to 2 now. And now looking for the maximum path through 2, which is the 7th cell in a grid, we can explore 3 possible directions, left, top and right. So all these values, which is 2 and 1, are either less than or equal to 2. So there is no use of exploring those. So we just have the maximum length retained to be 1 and we move on to the next element. So our next element or the final cell in our grid is going to be 1 and we are trying exploring that. So for 1, we can either go left or top. We can't go for other possible directions, which is bottom and right, since they are out of the bounds of the grid. So considering left and top, both the values are greater than 1. So the max path for both 2 as well as 6 is found to be 1. So we update the max path of this last element in the grid, which is 1, to be 2, which is 1 plus 1. So this is how we trace, and finally we have obtained with the memorization grid. So from this memorization grid, we have to return the longest length. So as we look here, 4, 3, 2, 1, 4, 1 and 2, 1, 2. So among these, the largest element is 4. So hence we return 4 as the maximum path length in this grid. So now let's look on for the complexity analysis for the same code. So here, taking m as number of rows and n to be the number of columns, the time complexity here is order of m into n. And now how that is computed. So for each cell, we are exploring each cell in our m cross n grid, which will take order of m cross n time complexity for sure. And for each cell, we are exploring all possible 4 directions, which is left, right, top as well as bottom. And we will not be exploring them in some cases where it doesn't satisfy our 2 base conditions. So hence, actually speaking, our worst case time complexity is going to be order of 4 into m into n, which is considered to be order of m into n. And speaking about the space complexity, the worst case space complexity for recursive stack will be order of m into n, and we are storing a grid. We are using an array as well as the memorization grid. So which will lead to order of 2 into m into n. So finally speaking, our space complexity overall is going to be order of m into n. So I have passed the sample test case as well as the submission test case for this problem. So now let's move on to our second problem statement. It states that imagine you're a sales manager at a retail store and you need to analyze the daily sales data to determine the maximum revenue you can achieve from any continuous period of k days. So normally here we are given with n days, that is we are given a sales data for n days and we can consider any consecutive k days from those n days and we have to find the maximum profit for those consecutive k days. So this is a task actually. So let's see the input format. So as input in first line we are given with 2 integers which are n and k, which are in turn the total number of days for which the data is provided and the number of consecutive days which we have to consider for computing the revenue respectively. And in our next line we are given with the sales data for those n days which we have got as input in our first line. So this is all about input, and as output we will be computing the maximum revenue which we could achieve for the consecutive period of k days from those n days, and we will be returning a single integer as output. So speaking about the code constraints, the value for n can range from 2 to 10, the value for k can range from 1 to n, and the sales revenue value will be a 1 from 1 to 1000. So let's see a quick example. So as input we are given 4 and 2 which are n and k respectively. And then we are given with sales data for n days, which is 4 days over here, which are 100, 200, 300 and 400. And we are asked to compute the maximum revenue which we can achieve for a consecutive period of 2 days. So let's do it manually. So first we will be considering 100 and 200. So the maximum revenue will be 100 plus 200, which is 300. So now let's hold it and we will consider the next two, which is 200 and 300. 200 plus 300 is 500 and it is better than 300, which we have kept it in hold already. So hence we are updating it to 500. Now consider the last pair, which is 300 and 400, and we are getting 700, which is better than 500. So finally we will be returning 700 as output, which is a maximum revenue which we have obtained for a consecutive period of 2 days. So now let's see the example 2. So here we are given with n and k values of 4, which means that the number of days for which the data is given is 4, as well as the consecutive days which we are going to consider is also 4. So we are just summing all 4 values and returning the results, which is 1000 here. So before moving on to the algorithm, let us take a quick look onto which approach will be optimal in this case. So we can apply a normal brute force approach where we will be having 2 for loops. The outer for loop will be traversing through each element, that is through through the profit of each day in those n days. And our inner for loop will be for traversing through this consecutive days. That is our outer for loop for n and inner for loops for k. That is for each, let us consider the first input. It is 100, 200, 300 and 400. So when we look for 100, we will be looking for 2 consecutive pairs. That is our first loop will be looking for 100 and in our next loop we will be looking for 2 consecutive pairs of 100, which is 100 and 200. So in similar way if we look for, this is a brute force approach, and our time complexity will be order of n into k, which in worst case will be order of n into n. So this order of n into n time complexity is not obviously the optimal one. So hence we go for an optimized method which is done through the sliding window technique, and then explain it in the further slides. So let's see the algorithm for this approach. So as input initially we are reading n and k, which are total days for which the sales data is provided and the consecutive days which we are going to consider respectively. And now as input we are going to read the sales revenue for those n days and we are going to store it into an array. And then we are going to initialize the sum value and max value. So sum value is normally used to store the sum of that particular window, and max value is to store the sum or the profit or the maximum revenue which we have obtained till now. So we have these two and we are initializing both to 0 initially. And now we are looping through array. That is, for each element in an array, we will be first adding it to the sum. And after adding it to the sum, we will be checking if our window size is less than k. So if our window size is less than k, it means that our window is not even full. So no problem, we are just adding a new value. But if our window size is greater than k, we have attained the maximum window size. So we can't just add a new value. It is required that we have to minus or deduce the oldest value which is present in the window. So that has to be done if the window is consisting more than k elements. So this is done for each element, and finally we'll be keeping track of the highest sum to the max variable, and we'll be finally returning the max variable, which is in turn consisting of the maximum revenue from any consecutive k days which is computed from the given array. So now let's see the implementation code for the same. So initially we are reading the values of n and k, which are the total number of days and the number of consecutive days which we are going to consider respectively. And now we are going to read the sales data for all those n days and store it in an array. And for computational purpose, we are going to initialize the sum and max variables to be equal to 0. And now we are going to traverse through each element in an array. And now for each element in an array, we will be adding the newer value to the sum. That is, first added to the sum. And now check if it is exceeded the window size. If I minus k is greater than or equal to 0, it means that the window size is greater than k. So the window size shouldn't be greater than k, right? So in that case, what do? We'll be removing the oldest value from the window. So the oldest value from the window here will be I minus kth index. So hence we'll be removing the I minus kth index value in an array from the sum. So we'll be doing it, and then we'll be updating the max value with the already found max value and this sum value. That is, if the currently found sum is greater than the max value which is computed already, then we'll be updating our max value to be equal to sum. Otherwise, we'll be retaining it as such. And finally, we'll be returning or printing the max value, which is in turn having the maximum profit that we can achieve through k consecutive days from the data given, sales data given for a sequence of n days. So now let's see the tracing for the same. So this is what is the input, that is the sales data for n days. So here n is 4, and let us consider k to be equal to 2, which is we are going to consider for 2 consecutive days. And as said, initially the sum and max will be equal to 0. And we are going to use the sliding window technique. And our window size is 2 now, so we will be considering the first two elements, that is 100 and 200. So we are initially summing it, and its value is 300. So our sum is 300 and our max is maximum of the 0 in the previous slide and 300 which we have computed now. So it will be 300 obviously. And now our next part. So what we are doing is instead of considering from 200, that is instead of considering 200 and 300, by considering from 200 we are using a sliding window technique. That is, we are sliding a window by one element at the right. So while sliding, what we are doing is we will be removing the oldest element from the window and adding the newest element to the window. That is, while considering 200 and 300, from the sum which is 300, we will be adding 300 which is the newest element and removing 100 which is the oldest element in the window. So hence 300 plus 300 minus 100 will be arriving at 500 as the sum. So our max will be the maximum of already computed max result and the currently computed sum, which will be the maximum of 300 and 500, which will in turn be 500 now. So let's move on to our last step, where we are sliding our window again to 300 and 400. So while sliding there, we are computing for 300. So while computing for 300, we are having our already computed sum to be 500. So from that 500, we are adding the newest value which is 400 and we are subtracting our oldest value in the window which is 200. So hence 500 plus 400, 900 minus 200, we arrive at 700. So our current sum is 700. So our max will be the maximum of previous max value and the currently computed sum, which is the maximum of 500 and 700, which is 700. So we will be returning 700 as output, which is considered to be the maximum profit or the revenue which we have achieved in any consecutive k days from the n day sales data provided as input. So now I have passed the sample test cases for the same, and now moving on to the complexity analysis part. Considering n to be the number of days for which the sales data is provided and k to be a specific time period for which we are going to find out the maximum revenue, our time and space complexity are as follows. So our time complexity is order of n. It is because we will be exploring each element only once. So for each element we will be spending an order of 1 time complexity. So our time complexity will obviously be order of n. And considering our space complexity, we store all the sales data for n days into an array, and hence arrays of size n, so our space complexity is going to be order of n. So that's all about the complexity analysis, and this is all about the two problem solution which I have explained, and thank you.